Hello, hello. Welcome to our third set of notes for Math 0305. In this set of notes, we are going to start introducing integers. That's a way of saying we're going to start seeing some negatives. So integers are those same whole numbers we've had previously, 1, 2, 3, 4, all the way up to forever. But now we also include their opposites, the negatives. Hopefully we're aware of that when we're looking at a number line, anything to the right side of 0 is our positives. And anything to the left side of 0 is the same distance, but considered negative. So when I mention the word distance, that brings us to a concept of absolute value. When we are asked about the absolute value of something, what we're asking for is the numerical value of it without wanting to know left and right. In other words, the numerical value without having to think about positive versus negative direction. The easiest way to think about this is the distance between that number and 0 on the number line. So let me back this up just for a minute up here to this number line. If I wanted to know the absolute value of, say, -4, what I would do is I'd ask myself, how far from 0 are we? 1, 2, 3, 4 places, right? 4 units. Essentially, it's the number 4 without the negative in front. So the way we symbolize absolute value is with these straight up and down lines. So the absolute value of 3 is 3 spots away from 0. But the absolute value of -3 is also 3 spots away from 0. Think about it. If I'm driving from Lubbock to Levelland, 20 miles, it's the same 20 miles if I go from Levelland to Lubbock. The direction I'm traveling doesn't magically make me negative. So absolute value refers to distance. So let's try a few. What's the absolute value of 7? Well, 7. What's the absolute value of -7? Still just 7. You can think about these absolute value signs as parentheses or groups, where I need to make sure and work inside of that absolute value sign first before I deal with something outside of it. With that being said, if I'm looking at number 3, notice how this negative is in front or outside of the absolute value sign. So I need to leave it in front. Then I can say that the absolute value of 7 is 7, giving me a final answer of -7. And last but not least, the absolute value of 0 is 0. Now, I understand that this particular example I'm about to talk about is not on your notes, but I would like you to add it. What if I had a negative in front of the absolute value sign and a negative inside? Well, just as I mentioned previously, anything outside of the absolute value sign just needs to come down. Because this absolute value sign acts like a parenthesis. It says, hey, you have to take care of what's inside of me first before I can deal with anything outside. Well, whoops, I'm jumping around a little bit. The absolute value of -7, without that box around it, is +7. And the negative in front comes down for a final answer of -7. So that's a good one to note because you might see it pop up again. With that being said, we need to go back to our adding and subtracting, but this time with negatives involved. So I'm going to go ahead and talk through some of these examples, look at some of the properties on this video. We will also have another video with a lot more practice. So when it comes to adding and subtracting integers, there's rules we have to follow. If we have the same sign we need to add the absolute value of the numbers together. Meaning, if I have a positive 8 and a positive 7, those are the same sign. So I add them together. 8 plus 7 is 15. And I need to keep the positive sign, positive 15. If I have the same sign, even though they're both negative, negative 8 plus a negative 5, they're both negative. I need to go ahead and add the values. So I'm going to add the 8 and the 5 together, giving me 13. But I need to keep the negative that we started with, negative 13. Think about it like this. If I'm $8 in debt and I bring in $5 more in debt, $8 in debt, $5 in debt, I'm going to put those together because they're going to bring in more debt, negative 13. Hopefully that makes sense. Come on, doesn't want to color. There we go. Debt plus debt, more debt. So again, if I have the same sign, add those absolute values, add the 8 and the 7, add the 8 and the 5. Then keep whatever sign you started with. If instead you have different signs, one positive, one negative, then you actually need to subtract the absolute values of your digits in just the normal way, the bigger one minus the smaller one. Then your sign, you will keep the sign of whichever number was larger. So an example, negative 8 plus 15. I have one negative and one positive value. So these were different signs. That means I actually need to subtract the values. The bigger one, don't think signs right now, think about just pure absolute value, 15. And I'm going to subtract the smaller one, the 8. Well, 15 minus 8 is 7. And then I need to keep the bigger sign. So when I look back at my numbers, 15 and 8, which one's bigger? Well, the 15 is. The 15 has a positive, so I'm going to keep the positive. So positive 7. Flip-flop that. If I have a positive 8 plus a negative 13. Notice one's positive, one's negative, so I still have different signs. Meaning I need to still subtract those values. When I'm looking at the values, I'm talking about the physical absolute value. I have a 13, the bigger one, and I have an 8, the smaller one. 13 minus 8 is 5, so that's the physical value, the absolute value. But in terms of my sign, I keep the sign of the bigger number. In this case, 13 was bigger. Since it's negative, I need to keep the negative sign. So when it comes to adding and subtracting integers, I have my little sign triangle. Plus, minus, minus. And this is to help us remember, if I have these same signs, if I have a negative and a negative, then the leftover, the plus, tells me I need to add the values together. So if it's the same signs, my triangle tells me to add the values. And then I have to remember to keep whatever sign I started with. If instead I have different signs, I have a positive with a negative, then this leftover one here reminds us that with different signs, I need to subtract the values. Then we have to remember to keep the larger sign. This can be done with any combination of adding and subtracting integers. Sometimes we might need to rearrange it a little bit. Sometimes we have double negatives to deal with first. Now, looking at 7 minus 9, I can rewrite this where I have a positive 7 and a negative 9 as my values being added together. So keep the sign that's in front of the number, just move it over and plus it. Now, because I have different signs, I'm going to subtract. 9 minus 7 is 2. And I'm going to keep the sign of the bigger number. Final answer, negative 2. That's a little different than what we're running into in the second example. When you have a double negative, now do not confuse this. There's a difference in this and this. Here, like we saw a minute ago, negative comes down, absolute value turns me into a positive. Okay, this is a different situation. It's not what I'm talking about. If I have a parentheses with a negative out front and a negative, it's a subtraction out front and a negative with my value, then what it's really saying is that I want the opposite of negative 5. Well, y'all, what's the opposite of negative 5? Positive 5. So when I'm given the problem negative 8 minus a negative 5, what they're really saying is I have negative 8 plus 5, because the opposite of a negative is positive. Please do not miss this. This is a very, very common mistake. It requires both of these signs. The first one is the crossbar. The second one is the up and down. It requires both of these in order to create the plus. So when I'm done, I have a negative 8 plus 5. Both of these have disappeared. It required both of them to turn positive. Once I have simplified that, those double negatives turn positive. Now I can say, once again, I have different signs. So let me subtract my digits, giving me 3. And I keep the sign of the negative. I keep the sign of the larger value, which in this case is negative. Okay, this video introduced us to the concepts of adding and subtracting integers. One thing to be aware of, anytime you are adding what we call the additive inverse, the positive plus negative of the same number, so 3 plus a negative 3, or a negative 7 plus a positive 7, those will always zero out. I'm going to go ahead and stop this video here. We've gone through our introduction. In our next video, we're just going to take the time to practice.